clothes are on the floor. Oh, don't wanna say goodbye. No, I want more. 25, 25, 7. I give you all my attention. Baby, you're my obsession. 25, 25, 7. I give you love and affection. Baby, you're my obsession.
Cutting me up like a knife and I feel it deep in my bones. Kicking a habit I love even harder. You wanna know? I just wanna dive in the water with you, baby. We can't see the bottom. It's so easy to fall for each other. I'm just hoping we catch one another.
Oh, na na, just be careful, na na. Love ain't simple, na na. Promise me no promises. Oh, na na, just be careful, na na. Love ain't simple, na na. Promise me no promises.
Baby, I think about you and I feel it deep in my heart. Maybe we just ain't meant to be something. Maybe we are. Ooh, I just wanna dive in the water with you, baby. We can't see the bottom. It's so easy to fall for each other. I'm just hoping we catch one another.
Oh, na na, just be careful, na na. Love ain't simple, na na. Promise me no promises. Oh, na na, just be careful, na na. Love ain't simple, na na. Promise me no promises. I just wanna dive in the water, but baby we can't see the bottom. I just wanna dive in with you. I just wanna lie here with you. Oh, na na, just be careful, na na. Love ain't simple, na na. Promise me no promises.
Promise me.
Oh na na, just be careful, na na. Love ain't simple, na na. Promise me no promises. Promise me no promises. Don't you promise me nothing.
Promise me.
Just be careful. Promise me no promises. I've made up my mind over and over. Keep pressing rewind, but I'm getting older. Tried every door, don't know who I'm looking for. And I've made up my mind over and over. I can't be everything you want me to be. I can't be everything you want me to be. Finally, I can see the light through the leaves, but it's all gone. But it's all gone. sounds like I'm alive, I'm alive, I'm alive, I'm alive, I'm alive, I'm alive. This is what it sounds like. I'm alive. Life sounds like I'm alive, I'm alive, I'm alive, I'm alive, I'm alive, I'm alive. This is what it sounds like. I'm alive. Break it down right here now. You be Bonnie, I'll be your Clyde. Hop into my car and drive like fireworks. We will ignite through the San Francisco night. Like John and Yoko, like Ice-T and Coco, like Jay-Z, Beyonce, come be my fiance. Hey, soul sister, I'll be your mister. Don't wanna be no one night stand. How many ways can I say to help you understand that I only wanna be your man? Life sounds like this is what it sounds like. And it sounds like I'm alive, I'm alive, I'm alive, I'm alive, I'm alive, I'm alive. This is what it sounds like. I'm alive. Bring it back one more time. Everybody wants me to be who they want me to be except you. All I wanna do is be with you. Life sounds like
Ladies and gentlemen, please take your seats. Our program will begin in 10 minutes.
sounds like life sounds like I'm alive, I'm alive, I'm alive, I'm alive, I'm alive, I'm alive. This is what it sounds like. I'm alive. Life sounds like I'm alive, I'm alive, I'm alive, I'm alive, I'm alive, I'm alive. This is what it sounds like. I'm alive.
I get high all the time. I get drunk on my mind. Call you at 5 in the morning. And I say what I like. And I don't like playing nice. I might pick a fight without warning. When it gets boring, I try to keep it cool and turn it down for you, but I'm never gonna change. And that's why I be saying, boy,
Mama Mavis, oh, mama, they try my patience. Is gone, who is left to save us? We mourn, I'm praying for my neighbors. They say the devil's at work and is calling favors. You say I'm dangerous, I speak for the nameless. I fly with the vultures, I be with them bangers. If change don't come, then the change won't come. If the bands make them dance, then the rain gon' come.
Am I passing through the light? Look into your eyes. All the world is out of your head. You got to die a little. If you want to live, change come to pass. You best be ready for it.
Something out the country feels about to change its form. Yeah, it's a shift in time, but I won't get tired at all.
Look into my eyes, mama, tell me what you see. Tell me there's a chance for me to make it out the streets. Tell me that I won't die at the hands of the police. Promise me I won't outlive my nephew and my niece. Promise me my pastor isn't lying as he preach. Tell me that they'll listen if it's lessons that I teach. Tell me there's a heaven in the sky where there is peace. But until then I keep my peace in arms reach.
Am I passing to the light? All the world is out of your hands. Another night, you got to die a little. If you want to live, change coming. Hey, you best be ready for it.
Something out the country feels about to change its form. Yeah, it's a shift in times, but I won't get tired at all.
Ladies and gentlemen, please take your seats. Our program is about to begin. And once again, as a courtesy, please silence all devices. Thank you.
Another night, you got to die a little. If you want to live, change is coming. You best be ready. Be ready. Ready for it. Be ready. Be ready. Ooh.
Do you recall not long ago when you would walk on the sidewalk? Innocent, remember, all we did was care for each other. But the night was warm, we were bold and young. All around, the wind blows, we would only hold on to let go. Focus, fire gun, we need someone to lean on. Focus, fire gun, all we need is somebody to lean on. Focus, fire gun, we need someone to lean on. Focus, fire gun, all we need is somebody to lean on. What will we do when we get old? Will we walk down the same road? Will you be there by my side, standing strong as the waves roll over? And the nights are long, longing for you to come home. All around, the wind blows, we would only hold on to let go. Focus, fire gun, we need someone to lean on. Focus, fire gun, all we need is somebody to lean on. Focus, fire gun, we need someone to lean on. Focus, fire gun, all we need is somebody to lean on.
Let's do developer conference. about containers and microservices,
Java, Java EE.
JavaScript and DevOps and mobile.
We need cool demos like this robotic arm.
You can have like an IoT workshop.
Hands-on labs. Good speakers.
Baruch,
Douglas Crockford.
Adam BN.
How about Chris Richardson? And we're gonna make it really big. Let's go global.
All around the world. North America, Brazil, Europe, Australia, Asia.
What are we gonna call this?
You can call Developer World.
No, Developers Code.
Oracle Code.
Oracle Code.
Oracle Code.
Oracle Code. Oracle Code.
Ladies and gentlemen, please welcome Director Oracle Technology Network, Stephen Chin.
Hey, and welcome everybody to Oracle Code New Delhi. Do we have any developers in the audience? All right, excellent. And everybody who didn't raise your hand, we're very glad to have you here to learn about development and technology, because we have a lot of great, exciting topics on containers and microservices, AI, machine learning, DevOps, open source, different languages like Java and JavaScript. So I hope you guys are here to learn something. But before I talk more about the conference, I want to talk a little bit to you guys. So let's chat with one of the developers in the audience. So actually, right before the keynote started, this guy came up to me. What's your name?
My name is Partha Pal. I work in RBS Bank, and I'm following Stephen, Simon, Sebastian, and other Java champions as well in Twitter, and recently bought Stephen's Raspberry Pi book.
Cool. So give Partha a big round of applause. So very excited to see lots of developers here in New Delhi coming out for the conference today. We have a big announcement. So we have a partnership with Docker where you can actually find Oracle products in the enterprise Docker store. So any of the developers here use Docker? All right, so now you guys can all use Oracle products directly from the enterprise Docker store. And you can go and find the commercial images on the store, open source images in our GitHub repo, and then more information at developer.oracle.com, which is our site for all things developer. Also, we have the Startup Cloud Accelerator, which was first launched in Bangalore and now is going worldwide with a bunch of locations opening up in Delhi, Mumbai, Sao Paulo, Bristol. So we're doing this across the globe, and it's a great way if you're a startup or you're beginning a new project. We give you support, we give you connections with VCs, and a bunch of the projects which kicked off this program are actually here at the conference. So there's a Startup Cloud Accelerator Lounge in the lower area of Building 18. Drop by, and we're also doing interviews with those guys on the Dev Live Twitter feed. So if you can, follow at Oracle Dev, and all day we're going to be live streaming interviews from the Code Lounge. We're doing it via Periscope. You just have to follow on Twitter. You'll see the live interviews going. We currently have one going on with the Startup Cloud Accelerator, so if you get bored of me or Sebastian, you could go and tune in and watch some of those going on. And then the rest of the day, we have different speakers, different famous people who we're going to be interviewing on the live stream. Also, get the mobile application for the conference. So on the mobile application, you can find the schedule. You can find the Code Lounge application, which will let you interact with different experiences in the lounge. And then drop by the Code Lounge, where we have the OBE labs going on. So those are 5-minute interactive labs. We have an IoT workshop. So we were just chatting about Raspberry Pi. So in the IoT workshop, you can get a free packet with a bunch of sensors, lights, and it hooks up to the IoT cloud, the back end. And we have a workshop where we walk you through that. Then we also have a demo with a CNC router hooked up to a Raspberry Pi and the Oracle Cloud, a demo with a cloud coffee station also hooked up to the Oracle Cloud and running Java technology. So it should be a lot of fun. Definitely check out what we have going on in the Code Lounge. So without further ado, I want to introduce our keynote speaker, Sebastian Daschner, developer, Java champion, and rock star. Sebastian? How are you doing?
Man, how's it going?
Thanks for coming all the way
Yeah.
from Germany.
Thanks for having me.
So where's your motorcycle?
My motorcycle. Oh, I guess we grabbed that in Japan, right?
Yeah, so actually right after this, Sebastian and I are taking a red-eye flight to Japan, and we're going to do a 3-week tour across Japan by motorcycle, live streaming interviews, visiting user groups, and talking about technology. So, also follow that and
follow Night Hacking Twitter handle if you're interested in that. We'll be tweeting a lot in these weeks, I guess.
And you guys are in for a treat because Sebastian is going to live code during his presentation. So there will be no slides this presentation. It's a real developer conference. So take it away, Sebastian.
Yeah, thank you. Thank you, Steve. So yeah, hi from my side. My name is Sebastian. I'm super happy to be here. This is actually my very first time in India when I arrived on Sunday. So I'm super happy to see you guys today. And I'm gonna talk about CQRS. So as Steve already mentioned, this is a developer conference, and I'm sorry, I'm a developer. So I'm really bad with slides and PowerPoints and all these, so it's only be code, and even the slides will be in the editor. I'm hoping you're fine with that. And this is also going to be a little bit interactive, at least we try this. So we have microphone runners. If you have any questions the whole session about either the concepts of the CQRS or the code and the live demo, feel free to ask anytime. Just interrupt me and somebody will give you a microphone. So this is actually the idea. And first of all, I have a few questions about CQRS on you, but let me first show you some slides, code slides about myself. So my name is Sebastian, I am from Germany, Munich, and I'm a Java consultant and trainer, or however you call it, so heavily involved with Java. I also love to help shaping the future of Java EE and the so-called JCP, the Java community process. So I'm in 2 expert groups there, and JaxOS and JSonP. And I'm also a so-called Java champion, and last one's Java 1 Rockstar speaker. So a lot of Java involved, and of course this will be also the topic of today. I would love to even do more live coding than I have, but on this topic, CQRS, which I will start right now, it's probably a good idea to show you some concepts first. So this is what I'm going to do first, and then we have some code, of course, and a live demo running on the Oracle Cloud. So as I said, if you have any questions anytime, then just feel free to ask. But at first, I have some questions for you. So just to get the feeling, how many of you have heard the concept of CQRS or are more or less familiar with it? Hands up. Oh, okay. Okay, I thought it would be more even, but yeah, thank you. No, that's good. So if you have any questions all the time, then feel free to ask. So about CQRS. And before we even start with that topic, you should always ask yourself, do I need all this? Do I need all this hype, new technology and everything? And why should we even care as developers, right? So first of all, I want to talk a little bit what's wrong with, or what's the shortcomings of the way we typically build enterprise applications. So in a CRUD-based way, right? This is probably, if you're an enterprise developer, this is what you should be familiar with, right? Create, read, update, delete, CRUD. And so if you have a CRUD-based application, right? You have a more or less monolithic application, or at least one monolithic database, and you're always storing a current state of your system, right? You have some domain entities, you have some domain objects, some POJOs if you're in Java, and they always contain the current state of your system. If you change something, then you have a new state of your system, right? And the old state normally is forgotten. And this is totally fine for most of the cases. But first of all, it lacks the reproducibility, right? So if you want to have the history or the whole context, like what happened to your system in the last 2 years that it was running in production, or how did it get to this current state, then you don't know, first of all, if you're in a CRUD-based system, because you only have the current state, right? And also, you have to think of transactions and being consistent, first of all, right? Because if you only have one current state and you probably have several sites changing something on your system, you have to somehow take care of that, right? You have to compete all the transactions and make sure everything's always consistent, right? And if you're in this monolithic application in a CRUD-based way, then you have to somehow deal with this problem, right? You have to synchronize, you have to make sure everything's always consistent. And this, per definition, can scale infinitively. So what you always have, you have some kind of monolithic system. Either if it's one application server, or if you have several application servers, you at the end have more or less one database in a CRUD-based way. And we talk about this more, why this can be a shortcoming. And now about the, about the concept of CQRS, I would say there are two motivations that come to this concept that I will talk later. And the first one is event sourcing. So if we talk about the reproducibility, like how do we know how the current system got into the state, then this kind of solves our problem. So event sourcing is we change our application that everything we do, every use case, every change is actually one event, and the whole application only stores these events. So based on its model, it doesn't store the current state. It only stores everything that happens to the system. The most famous example is money transactions, right? You have your bank account, and you start from zero, and you get money added and money subtracted over time. And if you want to have your current bank account, you start from zero, and you add all these transactions, you know? Plus, dollars, minus, and so on and so forth, until you have your current state. And in event sourcing, it's the same idea. You start from zero, and if you want to calculate a current state of your business object, if you want to have your domain entities, you start from zero, applying all these events, user created, user updated, and so on and so forth, until you have the current state. And of course, by doing so, you get the full history. You get the whole context, what happened to your system. Because everything that happens from the outside is stored atomically. And this can have, first of all, a few benefits, right? You have the full history. You can use that even for statistics. Or you can use it, what I would call future use cases. So if you're a developer and randomly your boss comes in and tells you, by the way, how many users did sign up on a Monday? Because, you know, managers do these kind of crazy questions. And you can say, I don't know, this was never a requirement. But in an event source system, you can say, oh, by the way, sure, I just go to the event store, get all the user sign up events, check for the timestamp, and calculate when the users did sign up. Because you have everything that happened to your system in an atomic way, right? So this is a big benefit. And now about the second motivation to CQRS. Because event source systems, by the way, good question. Who of you has built some kind of event source system in the past? Yeah, a few more. So these are actually quite common. They have been around since a couple of years, if you need them. And this can totally be done without CQRS and everything. And for CQRS, the second motivation comes in. Because now we're talking about event-driven architectures. And now even more the question, why should we care? So imagine now we're in a microservices world. Of course, always, you have to have a reason to do microservices first, right? So don't do them because it's just cool and because it's hype technology. If you have some kind of distributed system because of distributed teams, because of independent project life cycles, because of scalability, if you have several systems, then the whole thing with CRUD can be a problem. Why? Because if you have several systems involved and you want to maintain to be consistent, then you basically have to have distributed transactions, right? So if system A comes and needs system B in order to fulfill a use case, then the client calls the system A waits, synchronously calls system B, and the client has to wait all the time until system B returns, and this doesn't scale. Systems, it will never scale, right? It always blocks, and this is a bad idea. And in general, distributed transactions are also a bad idea. So try to avoid them. Well, but now if we have distributed systems, we kind of have to deal with this problem, right? We have to have use cases that stay consistent, even distributed over several systems, right? So the answer, or one way to solve that, is via events, via doing these event-driven architectures. So what you basically do, you take one consistent asset transaction and split it up into several ones that are, and this is important, consistent in themselves. I will show an example in a second. So that means you will stay consistent over time, but not in each and every moment. So that means you're basically eventually consistent. So you finish one use case, the user calls system A and immediately returns if system A can fulfill its internal database transaction, for example, and then asynchronously something happens to system B. And this is done via events. So in a similar way like event sourcing, these events are stored and then distributed. And I will show you now an example. As I said, I don't do any slides. This is ASCII art in editor. But to give you an example how this will work, let's order some coffee. So imagine you're at a coffee shop or at a restaurant or whatever, and you want to order a coffee, and that order system on the left, so we have 3 systems involved right now, and that order system needs other systems to finally fulfill that order. But you as a user come in and order some coffee with some coffee beans and a specific setup, and now the second system is needed to check if your order is even valid, if enough coffee beans are in stock. So on the top left, order coffee, the request comes in, and now, order system would have to call bean system to validate is this order valid, and then return to the client. As I said, this doesn't scale. Distributed transactions, this is a bad idea. So this has to be asynchronously. And this is done by doing events. So this event, the first system gets the order, place order coffee command, and now fires an event that the order has been placed. And this is it. It has been placed. It's not accepted necessarily, and it may not even remotely be possible to fulfill that order, but this is a fact. It has been placed, though. So these are immutable and happened in the past. This is now a fact to the system. The order has been placed, with, of course, all the data needed for that order. And now the client returned. It got an ID for that order, and it can come back later to the status. So it doesn't know, the client, if this order will be possible, right? So this is the deal with being eventually consistent. But now, the bean system comes in and listens to that event. And now the bean system will start to validate the beans, to validate the order, if the beans are available and in stock and so on and so forth. And then eventually, either the order beans validated event will be fired, or some kind of error like order not possible due to insufficient beans. And now the order system comes back, it listens to these events. So all these events are, of course, done asynchronously. And once that event comes in, order beans validated, then the order system knows what to do and says, okay, now it's actually accepted, and now it's a valid order. And then it updates its status internally. I will show in a second how that works. And now if the client would come back and ask for his order, we can return the updated status. We can already say, now it's actually accepted. And then it continues. Now, finally, the third system comes in. The barista is only interested in accepted orders. It says, oh, great, I can start to make my coffee. And the coffee brew started. And then accordingly, the status of the order will be updated, and so on and so forth. And then also the beans will be fetched. And then finally, the coffee will be finished, and the coffee will be delivered to the customer. And then you get the idea. The same thing happens. The systems listens to all these events and update their internal representation accordingly. And this is basically how it works to do that in a distributed system. And now about CQRS. So CQRS stands for Command Query Responsibility Segregation. Super long word. It basically means separating the read side from the write side. Or for developers as code, having a void method that does something but void doesn't return anything, or having a getter. Get something and it returns, but it doesn't have any side effect. It doesn't change anything on the system. So you either change or you read. And this sounds quite simple, but on the system it has quite a few implications. So that means you build up your system by splitting up a command side and a query side, and they solely communicate via events. As I said before, event-driven architecture, you have some kind of event hub or event store where all the events are gathered and then distributed accordingly, and all the systems interested in that consume the events and then update in their internal representation. Of course, in order to get that working, these events have to be handled reliably. And this is true for the event-driven architecture. Because, imagine, we now introduced being eventually consistent. So if your client asks for the status of the order, and in that very millisecond, the status is just updated on the other system, the client basically reads an old status. So then you're not fully consistent all the time. But mostly this is fine. So this is actually how all the big systems work. If you go to Twitter, if you go to Facebook, even if you go to your bank account, if I transfer some money to you, then my account will be debited, or that's the word, so it will be withdrawn from my account, but you may not see the money immediately. But eventually will be there. And that is important. That has to be sure that you don't let some money disappear and you don't create some money. So eventually it has to be consistent again. And this is the same story. So you have to be sure that all these events are handled reliably. So when the order command comes in for my coffee, I have to be sure that the order placed has been fired in the event store before I tell the client, fine, come back later. Otherwise, you may forget about the order, and this should not be happen. And now, some more ASCII art. So this is the basic architecture diagram. How this would work: you have a command service on one side and a query service on the other side, and they solely communicate via the event store in the middle. And I wrote database here on each side. It doesn't even have to be a database. So each and every service has their internal representation of the status of their domain entities. It can be in memory, it can be a relational database, it can be a NoSQL database, anything that can be optimized for each system independently. So this is the point. Now only the event store ties these systems together. So they are totally independent, how they manage their own technology, how they manage their own storage and everything. They solely communicate via events. And as you can see, they can even be distributed and replicated. So you can actually deploy several instances of each and every site because they solely communicate via event and they won't interfere with each other. So again, placing an order in our new architecture, of course it uses the command service side because it changes something, right? You want to place an order, you go to the HTTP interface of that command service, place an order, and now this talks to the event store, and then the order will be placed. And this is the moment where the client returns, thank you, come back later, we accepted your order, it has been placed. We don't know if it's possible yet, but come back later. Then, eventually, this event will be distributed to all the consumers. For example, on the query side. So all the query services, also all the command services, all of them update their internal representation to the database, to in-memory or whatever. And then eventually, if a client comes and says, give me the current status of the coffee order, it reads, of course, from the query side and gets the latest status there. As you see, being eventually consistent. If it reads a status before the next event has been published, of course it reads an old state. But normally this is fine, since the query side doesn't change anything on that side anyway. And of course, if you want to finally get your coffee, you have to process these events further, like I showed you before. So there will be an event handler on the command side that listens to these events and say, oh, now I have to do something. For example, the bean system. Order placed, now I have to validate. And this will be done in the event handler. And then, of course, subsequent events will be published coming from the command service, and so on and so forth. Any questions? Yes, we have a question over there.
Myself, Rajiv, I'm working as a full stack developer. So just wanted to know how this architecture different from Node.js. I mean, they have also event-driven architecture. And I also found some similarity between this architecture and Redux. If you heard something about Redux, if you can correlate, then it will be great.
Yeah, I'm not that familiar with the Redux architecture, to be honest. It also uses some kind of event-driven approach, right? So I don't know if it uses I don't know if it uses CQRS. So one thing about that it uses events to communicate, but the other thing is how it's done internally in the architecture, that it separates the writes from the reads. And I will show a little bit more of that in a second. So maybe you can compare it then to the Redux architecture. I'm not that familiar with that, I'm sorry. So I can't compare it, but then you maybe get the idea how it's done internally. So I will show that in a second, also in code, how it works. Yeah. And then you hopefully get the idea.
Thanks.
Yeah, thank you. Any other questions? Yeah, over there.
Hello, myself is Rohit. So why command server is interacting with the database? Isn't it should be handled by the events only?
Sorry, where is the database? I didn't get that.
So the command server is interacting with the database. Why? Like, isn't it should be handled by the events only?
Yeah, so the database on the command service would be needed if you need to validate something when the command comes in. So for example, on all the sites, the current representation is stored. And if some order comes in, and you already can tell from your internal representation of that system that it's not valid for some reason, then you can just reject it right away. So they also store the internal state. And I will show in a second why that is needed when we come to live code. So good question, yes. All of the systems normally have their own representation of the business object in a database, in memory, as I said, but these are normally needed in normal day-to-day applications. So, you normally validate something, you normally read something on the query side, and all this is stored in its internal representation. And the idea of the event store is that it only publishes the events, and it won't normally republish it. So it's published once to update the internal representation, and this is done, and then from your current representation, you do everything. You validate or you read. Yeah, very good question. If you have other questions, then just continue to ask and interrupt myself. And now about CQRS, some benefits of doing so. So now you see that you can, first of all, scale. Yes?
Yeah, I am Ashutosh. So my question is like the previous figure which you have shown, there is event store. That is a table or some database? Like event store you have shown?
Yes, it's neither. It's not a database, but it's an event store. So this is basically an event hub that publishes messages. So it's an asynchronous but reliable way of distributing events.
So it is in memory or something else? I just wanted to understand.
No, this is distributed. So it's a separate system. It's like a database, but it's not a relational database, but a system where you publish the events and then all the consumers consume the events. So publish subscribe model normally.
Okay, thanks.
But done reliably. That's important. Yeah. Another question?
Hi, my name is Chandra. Actually, this message event is something like a messaging queue kind of system where we push the messages and they respond.
Yes.
And how the command system understands those messages? It's a consume those messages and process the header and all, something like that?
Yeah, so you can basically use a message queue. The only thing that's really important that it's done reliable. So when I post a new message, when I publish a message, then this has to be done in a synchronous way. So that then the message queue says, I got your message reliably, it's persistent, and you can come back later. Then yes, you can use this. And for the event handler, so once you publish an event, and then you have an event handler, I will show this in the code later, in your application that also is a consumer that listens to the same events, but does not just update the internal representation, but it will trigger a new command on the command service side, as if you would have called that command from the outside, right? So then you got your new command and accordingly new events.
And how event handler respond back to the initiator? I mean, from where the process initiated, how it responds back?
It doesn't respond. This is the point. So you have a void method, basically. And at the very beginning, when the client comes in and places the order, and after that happened, the order placed, then the client is gone. It returned to the client, and now the client only has an ID where it can come back later and ask the right side, so the read side, the right-hand side, to give me the current status of the order.
So you mean to say that event store communicating with the query server, how query server is responding back to the command server?
It doesn't respond back. This is the whole point, that you separate it. It doesn't respond back. If you as a user want to write something, you use the command service, and if you want to read something, you use the query service. That's it. Both are not coupled together, unless the events. I'll show in a second, then you maybe get the idea how this works then, but this is really the principle. And there is no connection between, so this doesn't return or anything. It's really just one method called, and that's it. Then it's over.
Thanks.
Yeah, thank you for your question. So, as I said, now you can scale independently, since you are only connected. Oh, one more question, yes?
Hello. So basically you are saying just promises, it's like promises just works in JavaScript, right? If I'm getting right.
I'm not that familiar with promises in JavaScript, I'm sorry.
Okay. So it's
a promise is something like a callback?
Yeah.
Okay, yeah.
Fully asynchronous kind of thing. You just call something and just you don't want to wait to, for the response.
Basically,
you just do another thing, then, an event scheduler release the event and user listen to that event and just go further.
So,
right?
so it's definitely asynchronous communication, and in code it's even less coupled than promises, because you only subscribe to something and then you do something.
Yeah.
But yeah, the idea is definitely the same. Yes.
Yeah. Okay.
Thank you.
Thanks.
Another question? We have a lot of questions. That's good.
Hi, I'm Gaurav.
Hi.
I'm a full stack developer. I would like to ask you that how authorization and access roles can be managed in this kind of architecture. Also, that event sources only handling these authorizations as well in a particular scenario related to the streaming APIs. Like if I have video streamings, so how should authorization should be managed in that? Would you be doing that in the header part for the whole response, or the command or the query clients would be handling those? So,
so typically how authorization is managed as of today is that you have a third-party system and that uses OAuth, and then you have the authorization basically in a separate way, and it just gives you an HTTP header, for example, that tells you that this is valid. Besides than this, there is not a real difference, because typically on HTTP, the command service side, that will be post requests or put on HTTP, so you change something, but it will be a URL. So you could secure that URL in the same way like you do today in a monolithic system, but they are just, separated. But typically, as I said, you would use a third-party system, and then you would, using a proxy server, connect that up front to check, for example, if your authorization is valid. So this could be done in the same way. If you would use some CQRS stuff for it, for example, to manage the user logins, you could do so as well. This is just something that changed in your system, and then the user is logged in once that event is distributed. But typically, you would use OAuth or some kind of stuff like that. Yeah. Thanks for the question. Yes?
Yeah, this is Amit. And regarding the system, event system, as you just mentioned, so if like there are some sequence of events, like the example you mentioned, one thing is checking up the beans, validating it, and the second event is preparing up the coffee. So one requires a sequence. First you have to check the beans, then only you can place her coffee. So that kind of orchestration kind of behavior, will it be carried out by the event system or by the query system in the case as you mentioned?
So I didn't get the question. So yes, you have to have some kind of sequence of the event.
Yeah,
but the
sequence. Who is going to maintain that sequence? Is it the event system or the query system is going to check that this has happened, and it's going to kind of a checklist kind of thing it's going to do?
Yeah, so there is not a real system involved to do so, because the whole process of your order happens with all the three systems together. You know, if you would leave one out, then it doesn't work. So I get your question. The whole sequence is done by applying all these systems together, right? Because no system knows about the whole sequence. Each and every system just independently knows if an order placed comes in, for example, the bean system, I have to validate. That's all it knows so far. And if you look at the whole picture, like this, then you see, okay, it happens in that sequence, but no real system has this whole picture. This is the part of having this event-driven architecture, right? It only makes sense if you look at the whole picture, of course, but you don't have any system where you say, here is the whole workflow. Because for that workflow to work, you need to be distributed. This is the whole point.
So is there no workflow involved in it, you mean to say?
You would just document the architecture somewhere and have to have this picture, but there's no system involved that maintains everything, because the whole sequence is just applied like indirectly by having all these systems listen to all the events in the right order accordingly.
Okay.
Yeah, thank you. And now we're here. Once you can scale independently, because these are only communicating via the events, you can also scale each and every side independently. So you can scale out the query side or the command side. Because what's typical in enterprise applications is that the number of reads, the number of GET requests, highly outperform the number of writes, right? When you surf on Facebook, you hit F5 all the time, you refresh and you read, but you eventually post something, right? So typically, you would need much more workload on your read side than on your write side. And by applying this, you perfectly can do so, because you can just scale out the query side 100 times if you like. And the query side, then all your 100 instances will consume the events and update their internal representation in a database or in memory cache, and then return it to your high reading workload. And this is another good benefit of this approach, because you couldn't do that in a CRUD-based way, right? You only have one relational database, and you just can't say, please scale out all the read side. Well, you can have caches and all this. This goes into a similar direction, but it won't be consistent. So another nice side effect is you get read side failover availability because of that. Because imagine, in a CRUD-based system, if your database breaks down, that's it. You can't do anything, right? Because the database is gone. You can't read, you can't write. In a CQRS architecture, you can still read, because only the write side, the command side, will publish new events. And of course, this can't be done because your event store is down, right? So if your event store breaks down, you can write something, but all the caches, all the databases available on the query side are still there. So your clients perfectly can read, can continue to read your system. You just can't write anything. And now I want to show you more how that is applied in code. And if there are any questions, just feel free to ask. So what I've done, I've developed an open source project for that coffee shop. So you will see, this is now IntelliJ. Actually, we can close this for now. You will see 3 modules involved. barista beans and orders. These correspond to the 3 systems we saw. So these will be 3 independent systems and 3 independent deployments. What that is, these are 3 Java EE 7 applications. So we will use Java Enterprise technology to do our systems, and we will use Apache Kafka running on the Oracle Cloud. I will show that in a second. So actually a managed Apache Kafka version to be our event store. And all these 3 systems connect to that Kafka to communicate via the events. So normally, I would love to live code everything from scratch. So this is how I normally do my sessions. Unfortunately, this principle is a little bit too much to do so. And actually, if you apply CQRS in your projects, you will see, I will talk about this later, that one of the drawbacks is that it's much more complex to write than a CRUD-based way, right? Because in a CRUD-based system, you would write that coffee order, annotate a little bit JPA, and that's it, right? But here, you will have to deal with all these message consumptions and event handling. But let's just quickly go through it, how a typical workflow that we just saw in these slides looks like. So we have our entry point that is, in my case, a JAX REST resource. That means it is an HTTP entry. HTTP REST service that accepts some commands and will return some data. So now, just for convenience, this is one system, having both the read side and the write side. But they're not coupled together in any way. So this could be 2 systems. And this resource is the only way where they are coupled together. So as you see, we have some order command service and some order query service. And of course, if you create a new coffee, order some coffee, that will use the command service to place an order. And the order command service, that's a void method, by the way, as I said, will use the event producer that will connect to Kafka, will publish that event, order placed reliably, and that's it. Then it will return. Then the client, it knows some ID. The client can come back later and ask for that order. And of course, when it's published, then it's published to Kafka and all this. I will show that in a second. But this is it for the command side. And respectively, on the read side, it uses the query service just to read some order. And that query service goes to its internal representation, the database, and will return the current representation, the current state of your order. That is the coffee orders here. And what that is, if you're into domain-driven design, this would be an aggregate. So this is basically our in-memory store that stores the current state of our coffee orders. For my system, just to showcase you a couple of things, it does not use any persistence. So it would normally use a database right here. For example, a JPA database or whatever you want to use, a relational database, a NoSQL, some kind of persistent storage. Here, I don't even do this. I will explain in a second why. Here, it just stores in an in-memory hash map all the current state of all the coffee orders. And you see it has some @observes annotated methods. So this is, if you're familiar with Java Enterprise, this is CDI, events. So Java EE already comes with a technology that is event handling, CDI events. And in CDI, on an application level, in code level, you can fire events and consume them. And the way how I modeled my architecture together to work with Kafka is that if you consume a Kafka topic and then some message comes in eventually, then some CDI event will be fired internally. So you can listen to all these @observed annotated methods and update your status once an event comes in. And this is how this works. You have a hash map here, and once an event comes in, you say, oh, now you got an order placed event, so it has to happen this and that, right? A new order here has to be created, or if something else comes in, the order will be accepted. This is the update of the internal representation. And then you have your memory here, your in-memory representation, And actually this can be used, so internally, versions of that can be used in the query service and in the command service. That is the internal representation you use for your query service, you just saw that, to return the current coffee order. This is how it works. And in order to connect to Kafka, I don't want to go too much into detail here because it would kill our time frame. But as I said, you connect to the Kafka consumer groups, and once an event comes in, a CDI event will be published. The command service uses the so-called event producer to publish an event and sends it reliably. So this is how I configured Kafka to, if you send something, you have to wait to the commit, and only when the commit is done, this will return this method. So by doing so, you can be sure that the event has been handled and is persisted reliably. And as I said, on the update side, the same thing will happen by firing new CDI events. This will be the update consumer, and there's a lot of stuff going on there. And it basically, this is the other side of the at observes. So you can observe to an event, and this is actually where all the events will be fired. So that is done internally. If a new event comes from Kafka, a CDI event will be fired, and that will be applied. And also on the command side, if some, now you have to keep in mind that these are three systems. If some event comes in that originally came from the other system, you have an event handler, this is what I showed in the slides, that basically, on the command side, talks to your command service and says, now I'm on the order system, right? If beans validated comes in, now trigger a new command. Because I know that if the beans have been validated from the beans system, I am the order system, I now have to, well, accept my order, and that will continue the business process. That will continue with new events and continue the whole workflow and so on and so forth. And this is the component that takes care of that. That is done on the command side also. If you have any questions, just ask anytime. And now, let's run something, right? Let's run the demo. So what I'm using, oh, session expired. I'm using the Oracle Cloud because just recently there's a new service available on the Oracle Cloud that is in the Event Hub. And for us developer, it means it's basically a managed Apache Kafka. So you can use, here you see all this. So you can use this managed Apache Kafka version to build up a distributed Kafka cluster using Zookeeper and all the technology you're familiar with if you're using Kafka. And then, of course, you can set up what is called services. So I have 3 services. And what it basically is, these are 3 Apache Kafka topics. Because you saw my 3 systems, I actually could just do 1 topic. But you know, in order to be scalable and in order to separate all the things accordingly, you have a topic for everything related to orders, everything related to beans and barista. And these are basically the services there that are used. So this thing down here is, I think it's called platform. So it's basically the Kafka cluster. And these services up there are configured for each and every Apache Kafka topic. And this was just out recently. I can actually do this a little bit bigger so you can read. But the interesting stuff here is that you have several services there. And this is the service console from the Oracle Cloud. And this has just been up recently, as far as I know. So a special thanks to Bruno Borges, who's in that team and helped me a lot setting this up. So it actually was quite simple to set this up. And you configure your services to the Apache Kafka topics. And then you can use it as follows. So what do I have here? I'm not only a developer, I'm also a terminal and command line lover. So I have 3 command lines for my 3 systems. And I'm using Docker to basically deploy these. So I have a base image that uses whatever application server you like. I'm using Wildfly that already comes with Apache Kafka as a client. So I need the client API. That is basically, I can show the POM file that is basically Java EE plus Kafka plus JSON because it's internally encoded to JSON. And this will connect with the Oracle Cloud. So what I'm doing here, I will just actually, rebuild. I don't even have to rebuild it, but I have just one shell script that rebuilds everything. It packs everything into a Docker container. This is what you saw there. And then it bootstraps the application server. And what you see 3 application servers running as 3 Docker containers. And now there will be a lot of logs. And eventually, as you can see, some Kafka output. So all of them will connect to their consumers. So they have some consumer topics they are interested in. For example, the order system connects to the beans and the barista to consume all the other events and so on and so forth. And all of them, they're totally independent, Docker containers, will connect to the Oracle Cloud. You can now see I have 3 Docker containers running on my system. And now I can do something. Now I can order some coffee, right? And remember, I want to order some coffee, of course, at the order system. So I go to the order system, say, give me some coffee. It will then return. It will ask me to come back later to ask for the status. And the whole systems at whole, all the 3 will work together using Apache Kafka. So that means, as I said, I'm just working on the command line. You saw the 3 containers, right? I will now I don't use any orchestration. I have to ask for the IP address. So this is the IP address of my orders system, right? And I will create a new order. Of course, I'm using curl. Curl is an HTTP client, if you're not familiar with that. You can use Postman, any HTTP client, to connect with it. And it was IP number 2, right? This is the IP of the order system. It will post some new order. Oh, by the way, we want to order a coffee with beans from Colombia, nice beans, and we will want to have an espresso, right? And we're posting this to the order system, and what you can see is HTTP 202 accepted. We accepted your order. It may not even possible, who knows, but your order's in the system. And nicely, it also gave us some ID. So if you want to come back later, you can use this location to ask the order system, of course. That is now the query side, the read side, because it will use a get to ask for the current status. Oh, and what's that? It has been canceled. So this is the reason how the workflow works. You actually have to tell the bean system that it should store some bean. We will do this in a second. But you saw it. 202 accepted, although the order is not possible. There are no beans in stock. And now if you come back later, and this was later, you will see that it's actually canceled. So for a short amount of time, it was placed, but now it's canceled immediately. And if you look into the log of our application server, then you see this is the bean system, order canceled because order failed, beans not available. That's it. Beans not available, what happened? The order system placed the event, order placed, the bean system listened to it, used their internal representation, sorry, I have no beans, order not possible. And now, order system updated their internal representation. This is what you see the output from the HTTP. Well, we can do this again. Accepted, and if you ask this, it will also be canceled. So anyway, yes, question? Over there? So in order to get this working, we need to post some beans to the bean storage first. This will what we will doing in a second.
Hello, my name is Varun.
Yeah.
So I have a question. Suppose I'm using this CQRS framework, and this works for this use case. Now I have a second use case. So I place an order. I should immediately receive the request my order is accepted or it is cancelled. So
Yes.
how do I fulfill my use case with this CQRS framework?
Yeah, so it's accepted or cancelled. Yeah, actually, this is what we were doing. So if you wait for a second, I will now do an accepted order.
Okay.
So what we do, we can add some beans. So this basically uses the bean system. And yeah, it was the right IP, 03. Now we were posting some beans to the bean system. And if we ask our bean system now, then you will have the output. I have one package of beans from Colombia. This is now the bean system. It doesn't matter to the order system, but it matters in the whole workflow, because if we now post a third order, we still have HTTP accepted 202. And if we now ask for that location, oh, it's already finished. And if we ask again, it's already delivered. So what happens, same thing as before, but now the beans system says, your order is now possible, and now the whole workflow will be used.
My question was, for example, I'm hitting a request from a browser to the application server. So the application server handles the request with the all three systems, orders, events, and orders, beans, and anything. So on the browser, request should come like the event is successful or cancelled.
Yeah, and this doesn't work, because now it's eventually consistent. So now your browser won't have an immediate response. It will tell you, come back later. It will maybe have some spinner and then an asynchronous process to poll, but basically you says, it's in the system, but we don't know. And you have to come back later. And this is what I have done with my crawl request.
Okay, so for this kind of requirement?
Exactly. Now it has to be a requirement in your application that you're not synchronous anymore.
Okay, thank you.
This has to be part. Yeah, thank you. This is a very important question, a very important part. So the time is up, actually. If you want to have more hinters on that, I'm sorry we can't do any more questions. If you want to check out that project, you can actually, all of you can ask questions later, so I'll be around and I'll be doing interviews in that code lounge. This is the project that can be found on GitHub. It will use Java EE and Apache Kafka to connect to Kafka and to make all this workflow work. And everything you saw is on that open source GitHub project. And the second point I want to give you is a video course that I recorded that is available for free that shows the same concept that I showed to you guys in a more longer time. And it will also talk about beans and Kafka and show this in a couple of more episodes in a little bit more time. So if you have some more questions, I'll be around. Just hunt for me in the other room where the code lounge is. And then thank you very much for your attention.
Okay, thank you very much for that. So, great coffee example. If you guys want to find out more and taste some more good coffee, you can join us in the Code Lounge. Sebastian will be doing interviews at the Code Lounge, so please join us there. So without further ado, I'd like to introduce our next presenter, Thomas Kurian. He's the President of Product Development at Oracle. Thomas? How you doing, Thomas? So every time I come to the office here in India, the guys here, they tell me, you're here or you're coming here. You're constantly here doing things in India. What do you love about India?
First of all, I grew up in India. I grew up in Bangalore, where we have a large development center, and I grew up in India till I was 19 years old, and so it's still home for me.
Yeah, it shows.
I try to come to see the cricket from time to time, but I don't always get time to go to the matches. But we have a big development group here, and we do a lot of amazing stuff out of our India offices, and so it's part of the fun of coming and meeting them and looking at the projects they're doing.
Yeah, no, the teams here are doing a great job. Please give Thomas a big round of applause.
Thank you, Sue. Thank you all for welcoming me. I wanted to spend some time talking about our vision as Oracle for where we see technology going, and to show you with some real examples on what capabilities we're trying to deliver to our customers. Okay, so I have been at Oracle for 20 years. 10 years ago, in 2007, when we looked at where our technology platform was going, we saw that a lot of people were doing things that, in order to get to build applications, that they really didn't need to do. Right? 10 years ago, if you looked at wanting to build an application, you had to buy a machine, you had to put it in a data center, you had to cable those machines together, you had to have a DBA to administer the database. And so when we looked at it, we thought about how do we change fundamentally how quickly people can get access to our technology. And we rethought how fundamentally we would deliver that to customers. So we started with infrastructure, and then we added a platform layer and applications. And so today I'm going to talk about the details of what we're doing with infrastructure, because it's different than the way most people design infrastructure. And we're also changing how we think of delivering our platform technology to you. So the heart of our vision is around what we believe the cloud can do for people building applications. Okay, so let's start with infrastructure. What are we really doing with infrastructure as a service? It's really simple. We build ultra-modern, high-scale data centers where we put together hardware, which is storage, servers, and network them together. And then we expose them through a software API. And so the heart of what we're doing is we want people to be able to create in our cloud a virtual data center. Okay, so how does that work? You start by coming in, creating an account, getting yourself an identity, and then based on your role, you can create virtual networks, attach compute, attach storage, deploy load balancing in front of it, get DNS, and then be able to use other services like messaging, et cetera, et cetera. Now, how are our data center regions designed? So here are the locations in which we are around the world. We're adding India, as I said this morning. We're going to open a data center region in India. Now, but if you look at each of our data centers, each of our data center regions is typically a triple ring. Okay, so in any region, we have 3 data centers. Each data center is called an availability domain. They're on separate power grids. So if any one of them fails, you still have 2 of them available, so it's highly available. Between the data centers, we have dark fiber, and that runs up to 1 terabit per second with less than 10 microsecond latency. Okay, so it literally looks as though they were one big data center. Between the regions, we are building a fiber ring, and the fiber ring allows you to connect any 2 data centers around the world with less than 50 milliseconds latency. Okay, now these fiber rings use something called dense wave division multiplexing so that you can run very, very high bandwidth and multiplex many pieces of traffic over the fiber ring. And so we're able to get across the fiber ring multiple terabits per second. Okay, now you were going to click inside one of the data centers. So if you click inside one of those boxes and you get one inside one data center, the big thing that we built is an ultra-modern network. Okay, so what does our network look like? If you look at a traditional data center, the network is very tall. Okay, so as you add computers and storage at the bottom, your network becomes the point of bottleneck because it gets oversubscribed. Okay, now our network, if you look at our design here, any computer talks to any other computer, whether that's a storage system or a compute system, with a maximum of 2 hops. Also, every network path is redundant. So even if one network path fails, we have the ability to go over a redundant network path. Now, this infrastructure, this new, it's called a closed network design, and it's flat, and it's non-oversubscribed. So why does non-oversubscribed mean? No matter how many computers we have in our data center, you get very predictable, low latency compute performance down to any other computer or to storage. And that's what gives us an extremely good price performance when we look at people using the system. Third thing we did with our data centers, we moved virtualization. I think you all know what virtualization is. Traditionally, virtualization was done in hypervisors. We moved them from being done in hypervisors to being done in the network. Okay, so any two customers coming in come in over a private IP address space. Your IP address space and our IP and another customers are completely isolated. They're encapsulated inside the core network. So what that allows us to do is you get better security because your traffic is encapsulated from everybody else, but it also isolates your traffic from a quality of service point of view. So if somebody is running a big workload next to you, like they're running a huge MapReduce operation, sucking up a lot of data from storage, they don't take up all the bandwidth on the network. Okay? So how do we then present compute to you? So attached to this very fast, very wide-scale network are two types of systems: compute systems, storage systems. Compute systems, we provide three flavors. Bare metal servers, where you can literally go and get a Linux prompt or a Windows prompt, and the entire machine is yours. You can also get a hypervisor, or you can get a Docker container running Kubernetes under the covers as an infrastructure to spin up the container. Okay? On the storage side, we've provided 5 types of storage. On the compute servers, we provide up to 30 terabytes of DRAM and flash. Okay, so think about that. There's 30 terabytes of DRAM and flash on the physical server. So if you want to run a database that's 60 terabytes with 2-to-1 compression, you can fit the entire thing in memory. So these are extremely fast, very dense servers. If you want to share data across 2 different hypervisors or across 2 different servers, we support elastic block storage. And we have 2 kinds of block. We have flash or disk. So you can do either flavor of block storage that you want. Across the now, elastic block, you see it in the compute servers as block devices or LUNs. If you want to see it as files, you can run NFS, elastic NFS across these devices. Okay? And if you want to go across 2 data centers, we have object storage. And then if you want to save data and archive it, we have archival. Archival essentially allows you to put data in. Unlike block storage, we don't guarantee a certain recovery time, but it's much cheaper. Okay? So what have we done with infrastructure as service? We built high-scale data centers. On top of that, a big, wide network and attached compute storage with very high performance to it. So let me show you this. You can run any Oracle software on it. You can also run Windows. You can run a large number of open source tools on top of it. Okay, so let me show it to you. As I talk through the pieces, I'll show you some of the things that sit underneath. Okay? So first thing is, I want to get a cloud account. When you register with us, you can use username, password. You can also use a variety of social logins, your Gmail account, your Facebook account. Shortly, we're going to support GitHub as an OAuth client to it. You can use any SAML or OAuth token as a mechanism to authenticate yourself. Okay, once you authenticate, the first thing we ask you is to create what's called a compartment. What's a compartment? A compartment is basically an access control mechanism, so that if you have many different divisions or project teams in a company, you can put your compute and storage in an isolated compartment so that others can't access it. Okay, so I'm going to create a compartment. And everything I'm showing you in this demo is available through a REST API, and you can script against the REST API using Chef or Puppet or Ansible or whatever technology you want to script with. Okay? So here is a compartment I've created, and the next thing I'm going to do is create a virtual network. What's a virtual network? A virtual network is essentially the equivalent of your corporate network, your local area network in a data center. When you look at it, I'm not only creating the virtual network, but I'm giving the IP address block that I want to use. So it can look like an extension of your IP address range in our cloud. So I've created one. Now when you create it, the next thing you want to do is say, maybe your applications are not accessible from the internet. For example, they're ERP. But if you do want them accessible from the internet, you have to create an internet gateway. And when we create an internet gateway, what we're doing is giving you a public IP address through which traffic can come into your virtual network from the internet. So we're going to create one. Next, you're going to create subnets. Okay, so what's a subnet? Subnet is basically a software-defined network partition within that overall big virtual network that you did. Okay, so for example, you could say I want a private subnet on which I'm putting all my databases. So here is one. We're going to create one. And you can similarly create multiple. So most often, people create subnets for security reasons. They say, I want my databases on a private subnet, and I want my middle tiers on another one, and my web server tier on yet another one. And what we're doing with these subnets are creating security policies and rules that isolate each tier of the application from the other tier. Okay, so once you create the subnet, you're probably thinking, what would I create on one of these subnets? Probably a database. So you're going to go and create a database. Okay, so I can go and create a database. When I create a database, we ask you for a certain piece of information. The first one is, what edition of the database do you want? You can do standard edition, enterprise edition. If you want Oracle clusters, for example, you can do extreme performance edition. Okay, so here, I'm going to create extreme performance edition, which includes clusters. So I'm going to create one. And when I create one, we ask you for some configuration information. Okay, so what kind of configuration information do we ask you? For example, tell me the version number. So in this case, I'm going to create a 12102-based Oracle RAC cluster. Once you ask me for that, we create it. And then we're going to create a second instance, and it'll be clustered for you. Okay? So far, so good? Now you're thinking, okay, how do I create an application tier? So an application tier, we can create either a web logic-based middle tier, or you can say, hey, I want to build my own middle tier. So we're going to show you how you do a vanilla compute instance. Okay, so when I'm going to launch a compute instance, the first thing we ask is, where do you want to load, what image do you want to load on it? So we can create standard Oracle images. We have an Oracle Linux image, but you can say, look, I have my own Linux image. I've modified glibc, I've optimized how many packages are installed on it, and so you can create your own custom images, snapshot them and store them in the image catalog, and when we boot, you can say, use my image. So here we're going to take a custom image, and we're going to load it. Okay? When you load it, you have to tell us, do you want to load it on a physical server, or do you want it on a virtual machine? Okay, so BM stands for an entire server. VM stands for virtual machine. So here we're going to pick a hypervisor instance, a virtual machine, and we're going to create it. So when we create it, one of the things you have to ask for is the SSH key so that you can secure shell into it. And we can either generate the key if you don't have one, or you can give us a key and then we'll use that to give you access to SSH. So now we have created one instance. You can create a second one, and then they start. So we have created 2 web server instances running on compute. They're both in hypervisors. Now you may think, okay, I've got to load some images into those web servers because I've got pictures to load. So I need to attach storage to it. So what kind of storage can you attach? You want to attach a block device. So here is the storage. You can say, look, I have an availability domain. Within that, I created a virtual network. I attach compute to it. Now I want to attach storage to the same virtual network. So I'm going to attach storage. And when you attach storage, we created a block volume. And now I can say I want to attach it to a particular compute instance. So now I've attached compute instance and attached the block volume to it. Okay, so far so good. So the last step is, well, now I have multiple web servers. I have 2 of them, remember? I want to create a load balancing policy, similar to what you do with Big IP or one of those load balancing systems. So I'm going to create a software-based load balancer. I'm going to create the load balancer. When I create the load balancer, it asks you for a bunch of configuration information. Where are the origin servers, which are the systems that sit behind the load balancer to which I need to load balance? You can also specify the load balancing policies, like do I want to do random or round robin? And then we create a load balancer. Now, because you put the load balancer up, and remember that when I first created the virtual network, I created that internet gateway. The internet gateway means you can now receive traffic from the internet on that gateway address. It goes to the load balancer and down to the web servers because we set up the load balancing policies. So what have we done? We created essentially an application infrastructure that consisted, first I created my user partition called a compartment. I set up a virtual network. To the virtual network, I attached 2-node rack cluster database. I attached compute. I attached storage. I set up load balancing in front of it. Okay, so our vision for infrastructure is we've taken hardware, storage, network, compute, put them together, abstracted them through an API, and allowed you to create a virtual data center running in the cloud. Now, when you ask, today we showed you bare metal and hypervisor. Shortly, you will see in that choice list, you could see a container. And what we're doing there is giving you just a Docker runtime, and then you can invoke it and spin up containers using Kubernetes, for example, as an infrastructure. Okay, so that's our view for what we're trying to do with infrastructure as a service. What are we trying to do with platform? If I gave you infrastructure, but then you had to install the Oracle database, you had to configure the Oracle database, you had to manage it, you had to patch it, you had to back it up, you would still complain that there was a lot of manual work to do in order to operate Oracle infrastructure. So what our vision for platform is to take software and have software manage software. Okay, so what does software managing software mean? Today we run in our cloud, we run over 100,000 database instances. Okay, we only have 30 DBAs. Okay, it's not that our DBAs are really smart guys. It's that the software operates the databases. Okay, so imagine if you could say, look, I just need a database of this size with this much storage, this much compute. I want it backed up every day. I want it patched automatically whenever patches are available. I want disaster recovery configured, and I want it fully encrypted. And if CPU goes over 30%, scale it out. If CPU goes below 20%, scale it back down. Wouldn't that be much easier than what you do today? Now, the way we do it is not that we hired 100,000 DBAs at Oracle who sit behind the scenes and administer your database. The way we did it was to say, we're going to write a set of software that creates the database, configures it, backs it up, patches it, upgrades it, does all of it for you. And that's what we're trying to do with platform, is automate all the elements of software lifecycle management so you don't have to worry about it. So these are the pieces of the platform. You can manage data, you can build applications, you can put a large-scale data lake with Hadoop and Kafka, you can do analytics, you can build mobile apps, which we're going to show you, you can do a variety of other things. For data management, we support not just Oracle, but we can also run open source databases. So the same API that we have to create an Oracle database, slightly different JSON file, and we can create a Cassandra cluster. Slightly different JSON file, you can create a single MySQL instance or a MySQL cluster. So it's the same API to create any of these resource types, but behind the scenes, depending on what you specify in your, in your recipe, we create a different backend for you. Okay? For application development, we see 4 styles of app development. Okay? The first one is you build apps in Java EE. The second one is you build applications using a lightweight framework, which is I just want a Docker runtime inside of which I want you to support one of 6 languages: Ruby, Go, Java, Node, PHP, or Python. You can literally say, I just want a Docker runtime, allow me to deploy Node, I want to deploy version 2.x of Node, install the following packages for me, and monitor the response time. I don't have to worry about it. So that's the second style, called lightweight programming. Third one is I want to do microservices. So later this year, we're introducing an environment where you can say, here's my Docker registry, allow me to publish my Docker images there, and I want to spin up raw containers for me on managed Kubernetes. And then lastly, we're introducing something called functions, which I'll show you in a demo just now. So in a single cloud environment, you can choose your style of programming, and you can deploy it. Now, what do we see with DevOps? Okay? If you look at DevOps, we give you a cloud-based source control environment where you can check in code. It'll allow you to build, do dependency management. Once you're built, you can use a tool like Packer or Spinnaker to package your code. You can then call a workflow service to kick off orchestration. Now, depending on what you want to orchestrate, if you're spinning up virtual machines, hypervisor instances, you can manage orchestration through Chef, Puppet, or Ansible. If you're just spinning up Docker, you can call Kubernetes and spin it up. Or you can call different container runtime environments to spin up the appropriate runtime you want. Okay, now, one more thing. Remember when I said kickoff orchestration? What's that? That's an event that we're saying, I got a successful build, I packaged and shipped, now I'm ready to deploy. So what you're doing is kicking off a deployment cycle through an event that was raised. And so functions allow you to, instead of having to manually package and deploy, it gives you a mechanism to say, I'm going to call you over a RESTful interface or a Kafka event or an Atom feed, and based on a webhook, and based on when I call you, use that event to kick off an orchestration of some kind. Okay, now, a lot of that is what I'll show you now in a demo. Okay, so let me show you this. Let's start with, I want to create an environment to run a workload. I'm going to deploy a Java runtime and a database environment to go with it. Okay, so here you go. I log in, username, password. When I log in, this is the cloud dashboard you'll see. Okay, you can see all the different services that I am authorized to use. You'll see how much quota I have, how much resources are used, etc. Do you see that thing called Stack Manager down on the right side? What's a Stack Manager? A Stack Manager is, you can use the API to say, I just want to create a database, or I just want to create a middle tier. But a stack is a collection of things you want to create together. And you can define a JSON template to say, when I say a stack, what I really mean is I need a database, I need 3 middle tiers, I need a web server, and I need a load balancer to go with it. So when you create one, you don't have to have everybody create individually these things. You can create an entire stack. You can do that for databases. You can say, look, when I create one, what I need is I need a Kafka queue plus a Cassandra cluster plus a Redis cache plus 2 web servers. So you can create all of them. And so Stack Manager is just a way of creating services together. Okay, so let's go to the Stack Manager. When you look at the Stack Manager, the JSON file that describes the stack is called a template. And so here we have a number. We have Java and Exadata. So if you want an ultra-fast database and a middle tier to go with it, you can say, I want Java and Exadata. We have a Node and Cassandra stack. And anybody can write a stack of their own. You can write, frankly, we have a MongoDB plus Node stack. If you want to use mean stack. Here we're going to just look at the basic web application template. So let's look at that. When we go to basic web application template, the first thing we show you is the actual graphical view of the template. So when you create it, what we're going to do is create a MySQL database, 2 middle tiers, and a web front end. Okay, so in order to then use the stack, you have to give us some configuration information. Okay, so what kind of information? You have to tell us the details, name the stack, give us the config for the MySQL database. There's a couple of other pieces of config information. We confirm it and we'll create it. So once we create it, what you see is you have a database instance, and you have your Node.js environment and your Java environment. Java for the business logic, Node for the RESTful tier. Do you notice that there's no scaling template on one of them? So by default, you can say, I want to auto-scale all resources. Or if you forgot about it, later on, you can go and add an auto-scale template. So we're going to do one. Okay? So let's say I said, look, I want to add an auto-scale template. You can say, I want to take actions on it. You can stop, you can start, or you can scale. So when you scale, what you're really doing is defining a rule. And the rule goes into our software-based monitoring system that's going to monitor it. So think about it. If the average response time goes above a certain amount, then auto-scale it by adding up to 2 instances. You can also scale down. You don't have to just scale up. Normally, we recommend that you define a policy that says, monitor this metric. It could be response time, it could be CPU, it could be memory, it could be any metric. And we have a public metrics API into which you can define a metric. The rule is typically watch the metric, and if it goes above a threshold, but you should assume it should stay above the threshold for a period of time, because otherwise you may scale up and then scale down, and scale up and scale down, because if it just blips over the line, you're going to go up and down all the time. So normally we say build a metric, build a threshold on the metric, and if it goes above it, then scale. So we built these rules. It'll deploy it, and now we've configured auto scale even on the web app tier. Now the app is, now that I have the infrastructure done, I'm going to show you how to deploy the app. Okay, so here we're going to our developer cloud service. There's an application that we're building called the Address Check application project. So if I go to my Agile repository, what you see is you see all the check-ins that were done in the build system. And now if I then look at my actual build, what you see is this is my Jira system. It shows you all my tasks, what are complete, what are not, and what are waiting for me to do. So do you see the to-do for me? So I need to go and finish that task. So I'm going to go in and look at my code editor, and there's a code editor in line. And here it asks me to complete this task. So I'm going to go in and just add the code to finish the task. It's relatively simple. I just need to add a formal binding that the other person hadn't done. So I complete that, looks good, and I get a notification saying, remember to push the build. So I'm going to push the build, and the next thing I'm going to do is go and look at my build master. So in the build master, you see all of the check-ins and work that's going on in your primary code line. You can also go in and look at what builds are waiting to be promoted. Okay, so far so good? Now, let's say you want to go and look at a particular build. So I'm going to go in and look at a particular build, and I can see that the build has been created successfully. It has the complete build pipeline visible, and it looks like the build was created successfully and has been deployed. So later on, you thought about it and said, I don't want to be sitting in front of the build master to push deploy. What I'd really like to do is, if a certain function gets evaluated, think of it as a trigger, it will automatically kick off a deployment. So let me show it to you how to do that. That's where we call this thing called functions. So what's a function? A function is basically an event or a trigger that you can use to kick off anything in the system. Okay, so what kind of thing? Remember I said scaling? We said you can scale based on a rule. You can scale based on a function. If a function executes, scale out the system. If a function fails to execute, scale down the system. You can also use it to kick off a deployment. So here is a webhook or a trigger. And these are all mechanisms to basically make your development deployment cycle much more agile, because now you're tied it into a software-based infrastructure instead of having to have a human being sit there and press a button. So here it is. I'm going to implement a trigger, a snippet of code to implement this function. And in the future, whenever this function gets invoked, think of it as a trigger source. It'll kick off a deployment. And we will provide you a mechanism to kick off the function and an audit trail to see when was the function evaluated, how frequently, and when did it drive a deployment, so that you can see all the scaling activity or deployment pipeline in your system. Okay, so what have we done with platform? What we've done with platform, we showed you three things. First one was using a stack template to create an entire stack of infrastructure: database, web server, Node.js runtime. Second, we showed you how our platform as a service allows you to deploy a scaling environment, patching, backup, everything is expressed through policy. I showed you how to auto-scale. Patching is the same way. You can tell us, patch me between 9 to 10 on Friday nights, and we will patch you then. Backup is the same. You tell us, I want to back up my middle tier or my database, and I want it backed up every night at 10 p.m., we'll back it up for you. And then lastly, we showed you how functions and our DevOps capability can automate your whole build pipeline. Now, how do you deploy a Hadoop cluster or a Spark system? Same API. Exact same API. I asked you, how do I create a database? Remember that stack template? you can say, I really want to create an analytics infrastructure. And what's the analytics infrastructure? You can say, I want to create a Hadoop lake. I want to put the raw data in object storage, and from there spin up a Hadoop cluster. And because I have streaming data, I need a Kafka system to go with it. I want Cassandra as a NoSQL store, and then I want to use Oracle Analytics in front of it. And we can create the entire environment for you. You can also do the same thing for integration. You can build an API gateway. You can expose services to it. You can integrate to backend systems over service bus and add workflow and orchestration to it. Okay, so what we thought we'd do is show you a quick demonstration of how this works with an example coming from the mobile world. Okay, so in the mobile world, you look at it, and the real thing that's becoming very popular is messaging. Messaging provides not a browser, but a conversational interface with a backend. So I'm going to show you is a simple app. It's got a messaging interface. It talks to a chatbot, and the chatbot talks to an API in the backend. And I'm going to show you how easy it is to do. Okay, so let me show you this mobile phone. Can you all see this mobile phone? So since IPL is so popular, we thought we'd order some tickets to go to a game. So here is the API. This is the interaction with the daily daredevils. And I go on the site, on the messaging platform, and the first thing I'm asked is, hi, Thomas. Thanks for getting in touch with us on Facebook Messenger. Please send us any questions you have. So type in a message, hi. I post it, and back comes a message from the bot saying, welcome, Thomas, to the Feroza Kotla ground. How may I assist you? So I'm going to take next fixture, and what it did was say, here is when the next fixture is. Are you interested? So I say, of course, I'd like to see some tickets. It shows me the different places. Platinum Gallery looks good. So I'm going to select this offer. So when I select the offer, it's going to send me some information about what the offer looks like. So it says air conditioning, full dinner, good viewing experience, etc. Does that sound good? Shall we buy some tickets? So I'm going to say yes. And when I say yes, what it's going to do is order the tickets for me. Give me a confirmation screen. Here it is. It's going to place my ticket order, give me a confirmation, and then it's going to ask me, do I want to generate this to put in my Apple wallet? So I say, sure. Please generate it for me. Gives me confirmation, and then it'll put me into my Apple wallet. Okay, so what have we done here? We built essentially a bot that talked to a backend system and provided a conversational interface to order tickets for an event. Okay, so far so good. Now let me show you how we built it. So to build it, there are really three pieces to what's in the backend. The first thing we did was we used something called the API catalog. And the API catalog allows us to allow a collection of people to build and document and implement APIs. Okay, that's the first thing. So here it is. You can go in and sign up with your GitHub account. When you sign up, it shows you all the APIs available, but you're going to create one. So we're going to create one. It's called the Chatbot Backend API because it's the public API that talks to that chatbot backend. Okay, so on the left side is the parts of the implementation of the API, and then the right side, I'm going to say, let me look at the fixtures collection, which is a list of all the upcoming events that we have, right? And I'm going to say list all fixtures. So if I list all the fixtures, it gives me the HTTP URL that I'm going to, and then you can either do a mock implementation that you want to test with, or you can say, look, I'd like to implement that mock using Node. So I'm going to implement using Node, and what happens is you get the sample code. Okay, so that's going to implement that API so you can use to test your chatbot backend. So here it is. The response code comes back, and you can then document what that API is. It's called the Fixtures Collection API, and it's a list of all upcoming fixtures, games that you have coming up. You can also now share that API with a collection of other people who are going to be working with you on the application. And you can simply invite the others using email. Okay, so now the first step of enabling that messaging app was to build that API. Because that API is going to access the back-end ordering system to say list all the fixtures. Similarly, you would have a ticketing API to say order the tickets. You'd have a third API to say connect to Apple and send the digital signature over, et cetera, et cetera. Now I'm going to show you how to build first a set of policies on top of this. The first one is versioning. We have many different versions of this API, and you can see all the different versions. And frankly, if you introduce a new one, it should be backwards compatible and not break compatibility. So once you've built the API, you want to specify policy on it. So we call that API management. Remember that URL that we had that listed the API that you were building? I want to then express policy. So the first one could be security. So you could say, look, from a security point of view, I want username token. You could say it's just a public API. I don't need security. You can access access control of various kinds. You can also set up routing policies. So routing policy is various kinds. You can do header-based routing, gateway-based routing, or you can even do application-based policy. So in this particular case, we're going to base it on an application policy, and you can define that policy based on this particular service request. You can test it and then deploy it. So what we've set up essentially is a load balancing policy that handles routing to that API that I created. Okay, so first step was to create the API. Second step was to define policy management on it. Now you're probably thinking, okay, so now can I monitor that API? Yes, because you set a policy on it, you can monitor the API. There's not a lot of traffic yet because you've not made it publicly accessible. All this traffic is coming off what you're testing. Okay, now to create the chatbot. So what is a chatbot? A chatbot is a piece of software that does three things. First one is it understands your intent. When I was typing in get me tickets, what it said is it's an intent to buy. Translates that intent into a set of calls into the backend API, and then returns a response code. So what is a chatbot doing? It's doing only three things. It's understanding intent, it's maintaining the conversational state, the state of the conversation it's having with you, and it's calling different backends, right? So I'm going to show you that. So I'm going to create a bot. Here is a variety of bots that already exist. In our chatbot platform, you can start by just copying a bot. You don't have to create a new bot. You can copy a number of sample bots. Here we've got the Delhi Daredevils bot. So we're going to go down and drill into that. So I said you can edit the bot, you can clone another bot and relabel it. You can export a conversational log. Remember I said the conversational state? So if you want to test something, for example, you can export the conversational state and then replay it to test another bot that you've created, etc. So let's look at creating the bot. So when you look at it, remember I said the first step is to understand intent. Intent essentially is an action. And so I want to purchase tickets, I want to view the schedule, I want to see the scores. These are all actions. How do I express intent? On the right side, intent is created through what we call an intent guide. An intent guide says, here's a list of phrases that I'm going to give you. Can I buy tickets? It probably means the person is interested in the action, purchase tickets. I would like to purchase tickets. Next game. If you remember next game, I typed next game. And that's when it said, do you want to buy tickets? So it takes a set of phrases and translates them into intent. And intent is always translating a set of phrases into an action. Okay? So down below, we give you a simple way to test your bot. So you can simply enter a message in and start testing whether your bot is understanding intent properly. Okay, so here is intent entity. So when you create the intent, in addition to expressing phrases, you have to express various kinds of entities. Like, do you need assistance? Am I going to ask you to confirm your choice? Do you want to say yes or no? In which case, we'll put up yes or no, and you pick it, and we're done. So each of these things on the right, entities, they're essentially actions that you can specify back as a response to that conversation. So here it is. We're going to enter a sample message and test. So we enter a whole bunch of things. And when is the next game was a phrase we entered. Remember next game? We said it's a purchase ticket. Now notice we said when is the next game. So next game said it's most likely intent to purchase tickets, but when is could be seen as a question on schedule. But why did we say 0% is schedule? Because it's most likely a better response from the bot is to ask you, do you want to buy something, rather than saying, here's when the next game is. So these are all things that you can train your bot with so that your bot becomes an intelligent bot. Okay? So now that you've defined the value, you can then deploy the bot. You see the JSON response file for all the different actions. And on the left side, you get, if I define a custom yes/no field, what do I need to specify? I need your address, I need et cetera, et cetera. So what we've really done with this is to build, I showed you the app. A bot is really just a conversational interface on top of an API. And so to build a bot, you first need to define your API. You need to specify policy in the API. You need to specify the actions that the bot is going to take. We call that intents. Then you need to define how you translate user input into an understanding of event. And then intent entities are basically responses associated with specific intents. Okay, so now if you want last step, I want to make this accessible. And so to make it accessible, you have to tie it to a specific channel. So in my example, we were using Facebook Messenger. So to tie it into a channel, you have to specify the channel, and each channel has some unique authentication and access control mechanisms. So I'm tying it into Facebook's unique token format and access control mechanism. So you could do this with a variety of messaging platforms, and we separate how you define the bot, the API, and the conversation from the channel through which you deliver it, so that you can have the same conversational interface expressed across different channels. Okay, so lastly, if you're thinking about, hey, I'd like to try this, you can get an account in our cloud. You can go in and sign in with your username, password, or you can ask an Oracle person to get you an account, and then you can use the cloud to try the software. In the last, about 2 months ago, we had close to 80 students at Birla Institute in Pilani try it. They loved it. They built a whole bunch of open source apps on our cloud. You can do the same if you want. But if your company, if you work for a company that says, look, I'd really like to have this software in my data center, we also offer this software in your own data center. Okay, so last thing. Why did we build the cloud? For each of you. Before we built the cloud, if you wanted to try any of this technology, you had to buy a computer. You had to have air conditioning. You needed a data center in which to put the computer. You needed you needed an administrator. Why did we build the cloud? For every one of you who's a developer, what do you need to use our cloud? A browser, username and password. And you can get up and running. And we built it so that every person who's a developer can build great software using our technology. And so I encourage every one of you to give it a shot. Thank you.
Thank you, Thomas. So, you guys have gotten some very technical keynotes here. You can find more information at developer.oracle.com. So this is the website where we have like technology articles, we have downloads, we have information on the different Oracle Cloud services, so check that out. Also, we would welcome you guys to follow us at the Twitter handle Oracle Devs, follow us on Facebook, and also follow us on YouTube. For the first link for Oracle Devs, that's where you can watch the live streams on Periscope. So be sure to check those out. The schedule today includes a bunch of technical sessions. The technical sessions start in the afternoon. There's a couple hands-on labs as well, so if you've pre-registered for the hands-on labs, please show up for those. Those are going to be very exciting. We have a bunch of cloud accounts set aside for you guys to try our different services. And also, please join us in the Code Lounge, where we have all the technology demos, as I mentioned earlier, the live stream, the OBE labs, the IoT workshop. You can do all of those without pre-registering, so just come up and actively participate in those. And then also, come watch the live stream and the interviews going on. So we've been doing the worldwide tour. We've finished about half the cities. We're in New Delhi now, and we have a bunch more cities to go. If you have friends in Bangalore, encourage them to sign up for the event there, which is going to be happening August 4th. And we have a special offer for all of you guys in the audience. So if you have registered for the Oracle Code event, then you're entitled to a $500 cloud trial benefit. We have sign-ups in the back of the room. So in addition to getting the cloud trial sign-ups, does anyone here like t-shirts? So I saw the first hand go up over here. OK, the guys over there are saying, don't neglect. Sorry. Let's try one more time. OK, and I have a couple more for the center of the audience. Hopefully I won't hit the cameras. So thank you guys very much for joining us for the Oracle Code keynotes, and enjoy the rest of the content today.
Ladies and gentlemen, thank you for attending the Oracle Code keynote. Please join us in Hall 18 for the exhibition. As a reminder, breakouts will begin here in Hall 14 at 2:15. When you return, we kindly ask you to enter through the door number which matches the breakout location. Thank you.